Hello students, in last class we are discussing about the reactions of aldehydes and ketones, and in this class we are going to discuss about one more named reaction of aldehydes and ketones, that is a Mannich reaction. Mannich reaction. See here the aldehydes, and ketones which are containing the aldehydes and ketones which are containing alpha hydrogen or the compounds containing active hydrogen undergo condensation. Okay, these compounds on condensation with formaldehyde and ammonia, or the derivatives of ammonia like primary or secondary amines to produce beta amino carbonyl compounds, and these beta amino carbonyl compounds are known as Mannich base, and the reaction is called as Mannich reaction. See here what they are telling. The aldehydes are ketones which are containing alpha hydrogen. See, for example, R C double bond O CH3. Correct? If this R is an hydrogen, then it becomes aldehyde. Or if it is other than hydrogen, like any alkyl or aryl group, then it becomes ketone. And here one CH3 group is there. This is alpha carbon, and these three hydrogens are called alpha hydrogens. Okay, or other compounds which are containing active hydrogen. Other compounds which are containing active hydrogen means what? The hydrogens which are present on this alpha carbon are called active hydrogens. Why? Because these are involving in a reaction. Okay, these are actively participating in the reaction. The carbonyl compounds with active hydrogen. Okay, here these three hydrogens are there na? Those are called active hydrogens, and along with this they are telling formaldehyde, that is HCHO. Correct? Formaldehyde, and along with ammonia or primary or secondary amine. Here I am taking in general R2NH. Okay, this is secondary amine. Here in place of R, if hydrogen is there, then it becomes ammonia. This is secondary amine, and these carbonyl compounds will now undergo condensation to give C double bond O CH2 N. This is called Mannich base, or we can write this one as beta amino carbonyl compound. See here, this is the carbonyl group, this is alpha beta. On beta carbon amine group is there. Okay, therefore it is called beta amino carbonyl compound, or it can be called as a Mannich base. It is a Mannich base, and the whole reaction is called Mannich reaction, and it is called base because the nitrogen is containing lone pair of electron which can be easily donated. Okay, this is the Mannich base general reaction. We can see one example for this one Mannich reaction. Here I am taking acetophenone, which is having the formula of C6H5 C double bond O, CH3, acetophenone. When it is treated with formaldehyde, H, C double bond O, H, formaldehyde plus dimethylamine. Here secondary amine is there, na? There in place of R I am taking methyl group NH, correct? This is dimethyl amine, secondary amine, and this carbonyl group compound will undergo now condensation. C6H5, C6H5, C double bond O, C6H5, C double bond O, CH2, then this CH2, then NCH3 twice, correct? This is what Mannich reaction, and the formed product is called Mannich base. Okay, this is the best example for Mannich reaction. And coming to the reaction mechanism, the reaction involves following steps in its mechanism. Step number 1 is what? Formation of iminium ion. Formation of iminium ion from acid catalyzed reaction of formaldehyde. From acid catalyzed reaction of formaldehyde with amine. See here we have formaldehyde, C double bond O, H. Okay, this formaldehyde will undergo attack by the H plus of acid. Say these lone pairs of electrons which are present on the oxygen will drag this hydrogen, that is H plus ion, from the acid, and here we will get H, C double bond O, H, H. And as this oxygen is losing one lone pair of electron and forming 3 bonds, it becomes unstable and has a positive charge, and therefore being more electronegative as compared to the carbon with positive charge means it is unstable, and therefore it will drag one of the double bonded pair of electrons towards itself to get stability, and now this carbon will suffer from electron deficiency, and that electron deficiency can be fulfilled by the amine, that is CS3 to NH, dimethyl amine. Here I am using amine, dimethyl amine, and these lone pairs of electrons will now move towards the carbon. Okay. Here we will have, I will write CH3 twice, N, H, single bond CH2, OH, correct? This is CH3, NH, CH2, OH. And as this nitrogen is forming 4th bond, after losing a lone pair of electrons, it gets instability and forms a positive charge on it. And the next step is what? Dehydration. That is the loss of water molecule. The loss of water molecule takes place here. See, this bond will now move towards this nitrogen carbon single bond, and this carbon, as it is forming a new bond, it will lose this OH group. This OH and H will go as H2O, and here we will have CH3 twice, N double bond CH2. Okay, and this is called what? Iminium ion. This is called iminium ion. Okay, then the next step of this mechanism is step number 2. The compound with the carbonyl functional group now can tautomerize tautomerize to the enol form. To the enol form. See, we have a carbonyl compound having a formula of RC double bond O CH3. Okay. Now, if it is not a hydrogen, if this R is not a hydrogen, then it is a ketone. It is called keto form, and here it will undergo tautomerization. It will undergo tautomerization to form its enol, that is RCOH double bond CH2. This is called enol. 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 Here double bond is there in and OH is there enol. Keto enol tautomerization. This is the second step. And the last step, that is the third step of this mechanism, involves the attack of enol on iminium ion to form the final product, Mannich base. See, RCOH double bond CH2 plus CH2 double bond NCH3 2. I am writing the iminium ion like this. Okay, CH2 double bond NCH3 twice. This is iminium ion, and this nitrogen, as compared to the carbon, it is more electronegative. Being more electronegative in nature as compared to the carbon with a positive charge means it becomes unstable, and to get stability, it will drag these bonded pairs of electrons towards itself. Pi bonded electrons will now move towards oxygen, and this carbon will now live with only 3 bonds. Okay, and it becomes unstable and gets a positive charge. And to stabilize this carbon, this double bond will now attack. Okay, this double bond will now move towards this carbon to stabilize its covalency, and this carbon will drag this bond. The oxygen carbon single bond will now becomes a double bond after the loss of proton. Here we can write after the loss of proton, that is H plus ion. In first step we have used an acid catalyst. In the third step it is going out. Okay, R C double bond O CH2 CH2 single bond N CH3 twice. Okay, this is what Mannich base. This is the reaction mechanism. This is the reaction mechanism for a Mannich reaction. Okay, now take down the assignment question. Explain Mannich reaction with mechanism. Okay, explain Mannich reaction with mechanism. Thank you.